First, I don't know what's more intimidating, talking while you guys eating or these two bull elks staring me down while I talk. But the fireside chat, or the fireside talk is nice. Never had that before. So do you want me to speak with the microphone? Okay, yeah, we can try to do that. So is that better? Yes, it is. So as I mentioned, I also want to thank Water Street for having me here and my company BMS for allowing me this opportunity to come to Montana and speak to you guys about weather trends and the impacts to the insurance industry. So yes, I'm a meteorologist. Most insurance companies, or the big insurance companies, have meteorologists, just to let you know, and friends with pretty much all of them. Most of the brokers have insurance meteorologists. So insurance companies are weather companies. Insurance companies, need to understand weather risks. So it's just not coming from the Weather Channel. But so I won't take too much of your time today. Hopefully, I have a lot to cover, but we're generally going to look at just kind of review extreme weather risk perception. I think that's very important when we talk about weather trends and weather extremes. We're going to dive into those weather trends by looking at a couple of perils. I don't have a lot of time to touch on every natural catastrophe peril, but one thing we will dive into is hurricanes for some of those Florida clients here with Florida cliffs. And then we'll finish off with what insurance companies can do around that. But first, I want to set the stage with extreme risk perception. So I'm going to play a short little video here, and hopefully this works.
Extreme weather, 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 extreme weather.
So, extreme weather, one more time. As you can see, we're bombarded with the media telling us how extreme the weather is, right? I mean, this is, just straight from many of the news organizations we wake up and watch every morning or go to bed watching. So, but really, even though we're bombarded with this extreme weather in the media, did you know that, this year, we've only had $1 billion severe weather loss event, and it barely touched $1 billion, and it was PCS event 81, which caused a lot of that flooding and severe weather on the Red River Valley between Texas and Oklahoma. And you actually have to go back to 2007 to see a year with only $1 billion extreme weather event in terms of severe weather. Insured losses are actually running 45% below the last 5 years, with only that $1 billion event. For the hurricane, right? We've already known that, but just to put it in perspective, 3,608 days, right? That's to the date. How many days it's been since a major hurricane made landfall in the United States, and that was Hurricane Wilma. Despite the drought in the West, with the wildfires, which we just talked about earlier today, the number of wildfires is actually below average. It's the acreage which is up. And most of that acreage is actually driven by Alaska wildfires. And then we also are experiencing what some scientists call this Great Depression of tornado activity in the U.S. But, the notion of extreme weather in the media is nothing new. It actually started maybe back in 1939 with The Wizard of Oz, right? So you had the Cowardly Lion sitting in this poppy field saying, unusual weather we're having, isn't it? Right? This is also the first documented case of the media, manifesting extreme weather, transporting a girl and her little dog into an alternative universe. So extreme weather is really nothing new. In fact, it's really driven by this, armchair meteorologists. There's probably some of you in here. They're at an all-time high, right? Everybody thinks they're a meteorologist. It's never easier to get weather information from 4 cable television networks. In fact, just yesterday, the Weather Channel had a big shakeup again with their lineup and going diving into more of the core programming of weather and live weather, because that's what's driving the ratings that they're finding out, not Prospectors or some of these other reality TV shows that we're trying. So it's never been easier to get brainwashed with the notion that extreme weather is happening more, because we're getting it from so many different sources, such as blogs, Twitters, and these television. In fact, looking at the Media Research Center, where I pulled that clip from, it's kind of astonishing. So what they did is they looked at 2 different periods, a period of 2004, July 1st, through 2005, July 1st, and another period of July 1st, 2013 to 2014. Okay, so in that period, what happened July 1st, 2004 through 2005, right? A lot of hurricanes. However, only 18 mentions of extreme weather occurred during that time period. Fast forward to the other time where they pulled transcripts of the phrase extreme weather, and a whopping 988% increase in the phrase extreme weather, basically almost knew enough stories for one a day, or one every other day, for 196 stories. So if it bleeds, it leads isn't necessarily the case anymore. It's not just our media, the television, it's in our newspapers. This is a really cool tool from the New York Times, the Chronicles Lab, where you can go in and search for phrases or words like extreme weather. And sure enough, it's a little hard to see here, but there's a little bit of an uptick in the since basically 2000. Yeah, sure, there was extreme droughts in the 30s, the New York Times. Part of this is driven by, again, the New York Times has got to keep up with things. They got to issue more articles per day. And most of that's going to be driven by weather, since that's what people want to hear. But again, it's hyping the fact that we're hearing that phrase more often. But weather memory is really generational. I really want to hit home on this. If it snowed in Miami, that would be a huge deal today, right? But how many people remember? I wasn't even barely alive in 1977 to remember the snow that fell, okay? So we get a lot of that, and it's also in images. We have examples like this, dual twisters, side-by-side twisters from the Palm Sunday 1965 tornado outbreak that hit Midway, Indiana, right? That's pretty extreme. Oh, that doesn't happen very often, or does it? This is Flagler, Nebraska, just outside of Flagler, Nebraska last year, right? So we have and this was a big deal, Oh, this doesn't happen very often. It does. We just don't, we got to think back to when those times that do occur. And I just, again, want to highlight that we're just asking for trouble in the fact that our urbanization is out of control across the U.S., and when you have people building in areas that are prone for severe weather, basically Oklahoma to Dallas is one city basically now, or Tiki Island, just south of or near Galveston. But it's not just in the U.S., right? This problem's worldwide. We get our media worldwide. Just a little crowd participation here. I have 2 cities side by side. So anybody just shout out if you can think of these 2 cities here. Nobody. This one's in Asia. That will help a little bit. That's in the MENA region. That should be a little easier. No one want to guess? Come on, somebody. All right, well, we got Dubai. So we got one of the cities right. So Shanghai. Okay, that's pretty drastic development. Almost, pretty close to the same image perspective. When you put in the dates, it's even kind of more scary.
No way.
And this is what's scary to me, That's actually probably, if you're a reinsurer, one of the scariest potential disasters that's known that's going to happen. Because Shanghai is built on a tidal basin, very prone to typhoon risk, and that will all flood one day. It's just a matter of time. with the mention that there's been no urban planning associated with all that development since 1990. So let's carry on. Let's just keep in mind extreme weather and our trends here now when we talk about that. We're first going to hit on extreme weather. Where do we stand this year? Okay, severe weather hasn't been that bad. As I mentioned, there's only been that $1 billion loss event. Here, this is the plot of tornadoes in red. It's a little hard to read. We're actually about 300 tornadoes below where we should be, which is this gray line here. So we haven't seen as many tornadoes this year. Tornadoes are the driver of those large loss numbers, which is kind of why we've only seen $1 billion events. This green is hail, again, below the 10-year average line of severe weather. And wind, we're just a little bit below average, with just a few hundred counts below in terms of the wind reports from the Storm Prediction Center. But this isn't new, right? This has occurred since 2014. All were below that 10-year average, and even 2013, which is actually, was much lower. In terms of just trends, in terms of breaking out those last 10 years, so in the dotted line here, it's a little hard to see, sorry. That's kind of your 10 years. So you have, years like 2008, 2011 really stand out, but 2013, not a lot of tornadoes. Tornadoes are highly correlated with wind and hail. So you get a lot of severe weather, you're also going to get a lot of tornadoes and hail. But it's been basically 3 years where we've seen a lack of severe weather across the U.S. Let's put that in a little bit perspective, keeping in mind, when we do trends and looking at weather data, this data is only going back to 1950, not a long period of time to draw any meaningful conclusions about potentially a new normal or anything. But here we're looking at tornadoes, the weaker tornadoes of EF1 and greater, all the way up to major. And what this data doesn't show is there's actually an observational bias. People with mobile phones, storm chasers, all these are reporting more tornadoes now than they did back in the internet age, right? So if anything, if you were to detrend this, which you can do, which I didn't have time to show here, that we're actually on probably a downward trend. And one way to kind of to show that is by looking at the EF3 tornadoes or greater, right? Because if an EF3 tornado occurred in a farm field back in the 1960s or 50s, it would definitely damage the farmer's crop, and he probably reported that to the newspaper, and it was much easier for the people to go back and build that historical record. So there's less bias in those observations. So there's a little bit downward trend, but we've have had some pretty significant years with more violent tornadoes than we particularly have had just in the last 3 years. Like 2011 stands out, if I can get it out of the way, with a lot of tornadoes, and that showed up in the losses, right? So where do we stand year to date in terms of PCS loss? 2011 again stands out pretty drastically, and the number of events have been pretty stable. But there's a quantum shift of some sort that happened in 2008, which I can talk to you about, in my opinion, of what's going on with this. We're just in a new realm of how people view insurance and contractors and storm chasers and these sorts of things since 2008. But overall, we're still running below where we really should be in terms of severe weather loss. If and we can all say what we want about PCS, but it's really the best data I have to work with. But the point is I'm going back to that growth, right, which I talked about. If you normalize, look at some research done by Kevin Simpson and Roger Palicki Jr., they've taken those tornadoes that might have happened in the 1960s and 70s in urban areas now that are developed, and normalize what some of those economic losses might be, and it stands out to be, yeah, sure, back when we had like the 1965 tornado outbreak with some of the most tornadoes ever, it'd probably cause a lot of damage today. So it's important to put some of that into perspective. So let's kind of talk about winter risk. winter risk is getting critical in the sense that it used to be the cost of doing business. And more, especially the last 2 winters, we're seeing winter-related losses really eating into the company's first quarter profits, which tend to be normally pretty quiet. So when you look at that, we're seeing more winter-related losses. But according, this is using PCS data and from the Insurance Institute of Information, actually they're saying that winter storm losses historically over the last 10 years are the 3rd leading cause of insured loss, which is kind of surprising when you consider what grabs attention is the hail and wind, and obviously we have the tornadoes and the hurricanes there being 1st and 2nd, but winter storms 3rd, right? That should maybe start to wake up some insurance companies to start paying attention to that. But I just want to highlight, that we also have the same problem, and I'm going to just play another quick video.
Now, folks, if you are listening to the sound of my voice, first of all, open your eyes. Now, if you are listening and watching from anywhere east of Seattle, Washington, I hope you thought you would have stocked your soup cupboard and have picked out which obese relative to slice open and crawl inside for warmth. Because, folks, this is no ordinary cold snap. This is a monster.
This is essentially a hurricane. It swirls and it swirls at 100 miles an hour. That's our polar vortex. Polar vortex.
Polar vortex. Yeah, polar vortex.
We could have thunder snow.
Thunder snow?
Yes. We're being hit by a polar vortex and thunder snow. And frankly, folks, I'm not sure if those are weather patterns or finishing moves from Mortal Kombat. And as a newsman, I want to salute whoever came up with the term polar vortex. It is terrifying, but still sounds all sciencey.
So yes, just again to reiterate where I started, right? So we have this media going crazy, calling this, a hurricane at the pole, creating all this cold weather. We have to be very careful, and that feeds directly into the policyholders that eventually start to sensationalize this. But it has been cold. How cold has it been? Okay, well, we have 2 years, the last 2 years, 2013-14 winter, 2015 or 14-15 winter. And the numbers here represent the state ranking of how cold it is. So nothing was record-breaking in terms of the cold in the Midwest, even though it was cold. Last year, it wasn't a prolonged period of cold, but it was cold, but nothing, much below, nothing near record-breaking or just below average. And part of that's just because how prolonged the cold weather resulted. But what's important here for the insurance industry is, 2013-14, we had 6 PCS events totaling $2.3 billion. 2014, we had 8 totaling 2.9. We're just over 5 billion basically, and all that's adding up to the insurance industry, right? So it's the cold and the snow. But again, weather memory is generational. It's been cold in the past. Okay, the 1970s were brutally cold, just to highlight on the Time magazine covers here. Snow jam, right? That was a big news thing, right? Atlanta's had snowstorms before. The problem is they're seeing a 111% increase in population between those 2 events. Granted, cars actually probably drive better on snow now than they did back in the 1980s, but it's still a population problem. But it's been cold in Atlanta before. It's been cold in the Deep South. When you look at snow, yeah, okay, 2013-14 winter was snow, but we've had snow years. Take the year where the Metrodome roof collapsed in the upper Midwest. That was a really snowy year across the U.S. But also, so were the 1970s, as we just showed in the Time magazine. Last year, we actually didn't have a lot of snow over the West because the West didn't have a lot of snow. There wasn't a lot of snow into the Deep South. But it was cold, right? And another way to measure the cold is looking at Great Lakes ice coverage, right? If you can freeze a lake a Great Lake, it's pretty cold to have that, right? To release all that heat. You know, so we've had a lot of ice coverage over the Great Lakes the last couple of years. And that also occurred back in the 70s when we had the cold. So it's important to kind of point out, you know, these patterns come and go, and we've seen similar cold weather in the past. But it's really a loss issue. So the problem here is, you know, we're seeing larger losses the last 2 winters. You know, what we're looking at, you know, but we, you know, and there's definitely a trend upward in this winter weather losses, but the trend probably has to do with that population and the normal, you know, if you were to normalize it. So one way to kind of even just look at that is the number of PCS events. So taking that same data roughly and looking at the number of events, which are the red bars, you know, we had a lot of events, winter type loss events in the 1970s. So that's, you know, so that's one way to kind of picture that. So the last weather trend I want to kind of look at is hurricanes. So that's really the driver of loss historically in the U.S. But happy Hurricane Day, everybody. Do you know today we're halfway through the hurricane season? We're at the peak. It's downhill from here, right? That's good news. We also have this giant warm water in the Pacific Ocean called El Nino, which should still put a cap on hurricanes and limit development and hopefully limit any interactions to the U.S. coastline, but can't be, you know, there's always the exception. So we're halfway through, but it's been actually pretty active worldwide. So this is the global frequency of named storm activity, looking at all hurricanes and the majors. And in fact, the majors, there's been probably historically the most major hurricanes this year than that's ever occurred. They're not in the Atlantic Basin. They're in the West, they're in the Pacific Basin. But, you know, we don't really care what's out in the open water, we care about landfalls. So let's look at some different type of data here. This is the number of landfalling cyclones. You know, stopping kind of at 2014, there's actually, you know, really not much of a trend there. And we're looking at this in the sense that landfalling storms, we have probably some of the best records than what we have historically in the open ocean, right? So since satellite data, we have much better data. But landfall data, using data from the 1970s, you know, there's definitely a period where we're at the second lowest period for landfalling cyclones. That's hurricanes, typhoons, and cyclones in Australia, around the world, right? So even the past 4 years, we've only seen a total of 50 landfalls. That's the lowest total since 1982, right? And just you know, the historical averages here, we should see about 15. So this year, even though we have had a lot of typhoons in the Pacific, really only 3 or 4 or 5 of them have made landfall. Not a lot. But we really care about the Atlantic activity. So let's look at Atlantic activity as a whole, all the way back to 1900s when the records start. Again, not a long period of time. And we have to understand there's different ways of observing these hurricanes more recently than there have been. But in that pattern, we can generally pick out distinct periods of time where we've seen more hurricane activity and less hurricane activity, and we're going to talk about that in a minute. But generally, you know, yeah, the last few years we've been in this active period basin-wide. But in terms of landfalls, we're on this downward trend. You know, on landfalls, we have actually really good data, right? Because you're going to document when a hurricane makes landfall, most likely. In fact, today is the anniversary of 115 years ago of the Galveston landfalling hurricane. And I think it's also the anniversary of the Marathon, Florida hurricane made landfall on this date today. So it's definitely the peak of the hurricane season, but we're seeing this downward trend of hurricane landfalls in the U.S. in the period of record. And it's unprecedented, right? So I brought up that 3,600 and some days, and where that stands out here in terms of the landfall, the number of days between major landfalls. So what this is looking at is we've had 78 major landfalling hurricanes in the U.S. This is, major hurricane 1, 2, 3, 4. And the number of days that you go in between those, this bar line jumps out. So I was asked earlier, well, is this dumb luck? Yeah, a lot of research has been done now. It's, statistically, again, we don't have a lot of events here, only 76. It's probably just a frequent, a statistical anomaly. So what's driving weather trends? And we'll look at hurricanes as an example. So there's many different climate forcers that we look at as meteorologists in the insurance industry, and we've all maybe heard of ENSO or El Nino this year. There's the PDO, which can drive severe weather. There's the AMO, which a lot of people in Florida might have heard, which drives, it's a circular, which we'll talk about in the next slide, but there's a bunch of other different climate forcers, solar, volcanic, eruptions. But the AMO, we're going to talk about. Let's dive into that, because this is important, because it's a warming or cooling of the Atlantic Ocean. We know warm water feeds and allows cyclones to develop much more easily. But we're looking at data. This data actually goes back to 1856, and I'll take, again, different methodologies, right? This was a guy sailing across the ship, putting his beer down, throwing a bucket over, putting the bucket on the warm deck, taking a sip of beer, then measuring the temperature, and then documenting it. So, we got to be careful how we look at data, okay? I just want to point that out. But we definitely know that there seems to be a 30-year cycle of this AMO oscillation, and we know warm water feeds hurricanes, and we know we've been in this AMO for at least 20-some years now. So if this oscillation is correct, we should be coming out of that. So the AMO is maybe slowly fading. Is that why we haven't had a lot of hurricanes make landfall? Because there's definitely this tendency of more landfalls, which the blue and red are the major landfalls. So we have the blue lines as hurricanes making landfall. We definitely know as we approach 2020 that we'll be pretty much close to this warm AMO. It started off pretty active, right? 94, 95, all the way to basically 2005, we saw a lot of landfall activity across the U.S., which kind of matches this period. But since then, that statistical anomaly has happened, and we haven't had a lot of landfalls. But if we're coming out of that warm AMO, what do we need to look at as an insurance industry? So as part of what I do at BMS, we're looking at this, right? So we're looking at what happened in this time period. What should we start to see? How can we adjust rates in the CAT models, et cetera, for that? But first, we need to understand the AMO and that progression, right? Okay, so what you're looking at here is a bunch of sea surface temperature maps. They probably just look like blobs back there, but the east coast of the U.S. is here, South America, Africa. This period of record is sea surface temperatures in basically early 50s, 1951 through 1956. Lots of warm water, lots of green and yellows. Okay, 1954 to 1960, you're starting to see some cold water develop and not as much warm water basin-wide. As you get 1967 to the mid-70s, or mid-70s basically, you start to see less warm water, more cold water starting to show up off North America's coastline. And as you start to get in the cold part of the AMO, you see more cold water, right? Well, why is it? Why did I just show you this? Why do I think it's important? Because if you look at the sea surface temperature pattern, where do we stand today? We have a lot of warm water off the East Coast. The cold water's up off Newfoundland and Nova Scotia and the Maritimes, and the cold water south of Africa. So we're starting to get that similar pattern of sea surface temperatures that we saw in the tail end of the AMO. So why is that important? Well, because these sea surface temperature patterns drive generally the circulation patterns of pressure, and we will start to see general patterns of hurricane tracks. So if you look back at that tail end of the AMO, where the hurricanes been, You know, in the late 1950s, the 60s, at the tail end of the AMO, they were all on the East Coast, right? You know, Donna came up through Florida, but where have the hurricanes been, right, for the most part? Earl just missed the East Coast. You had Irene hit the East Coast. You had Sandy move up the East Coast. 2013, really nothing. 2014, we had Arthur and the 2 Bermuda storms. This year, you know, it's an El Nino year, so it's going to probably be a little bit different, not necessarily going with what we're showing here, but we're seeing maybe this trend of more storms potentially impacting the East Coast than other parts of the U.S. So we tend to try to work that in and work with our clients, you know, and growth strategies, et cetera. So what can an insurance company do? As I close up my talk here, you know, let's understand risk. Like, we're all weather companies. Y'all have probably access as a meteorologist through your broker. If not, contact me. We'll become your broker and help, right? And this is so we look at loss data. So we mentioned winter storms. It's very important to look at weather data and determine the best data loss, when to group those losses into a CAP program, right? We do that a lot. And then we go, you know, and we can better sell that to the reinsurance program. You know, utilize the CAP models. They're pretty different. This is a look at winter storm modeling. Yeah, there's winter storm models for the CAP models, so they just don't do hurricane and severe weather. But they're drastically different on their view of risk in terms of AAL across the country, right? Especially in the Southeast between these 2 models. So utilize that. Utilize your loss experience to validate the models now that we're getting a couple of years of data with some severe winters. Or you know, it doesn't have to be necessarily winters. This applies to hurricanes and severe convective storm, et cetera. You know, but really just understand where you're writing your risk, the relativities of that. This is looking at severe weather with the BMS Severe Storm Relativity product, which I've all given you things you can hang up on your desk. That one side is this BMS Severe Storm Relativity, because there are pockets of severe storm climatologies that are at higher risk, like Baltimore with the convergence of warmer air off the Chesapeake Bay and the leeward side of the Appalachian Mountains produces more severe weather. Climatologically, there's a meteorological phenomenon going on there that drive that. The Appalachians you're not going to see. So it's not necessarily driven by population observations. We've kind of tried to remove some of that here. But, you know, understand where you're writing that risk and apply it to your growth strategies and, you know, rating, by-peril rating, these sorts of things. But most importantly, going back to where I started, don't overreact, okay? Extreme weather happens, you know. Just today, and the flooding that we're seeing in Japan on the news that's making the headlines, that's happened before. That's a 1 in 50 year rainfall event. That's happened before. Just do we remember 50 years ago and the development that happened in Japan. So don't be misled by one extreme weather event. You know, one event doesn't mean it's necessarily changing the frequency or severity. Understand the weather trends that you're working with. You know, insurance companies can't really control the weather, but you can mitigate its financial impact. Take ownership, explore the links between the weather data and your business, identify the direct cost, gather that weather data, use the CAP models, build a tailored weather product, right? The ag industry does it. Best Buy is doing it. Starbucks is doing it. They're all offsetting their weather volatility risk by tailoring, you know, weather indices products. The insurance company can do it too. You know, and then, you know, again, look at that data and look at the sensitivities. So that's all I think I have today. And I'm happy to meet with all of you if I haven't talked with you yet. And once again, I want to thank everybody for your time and let me talk through your lunch. So, and I'll take any questions.
What's your opinion on global warming?
I knew that would come up. Yeah, let's get to the meat. Let's turn the heat up in here a little bit. So I'm not a climatologist. I don't speak to that necessarily. You know, there's other experts in that field. I'm a meteorologist. I think I personally view it's very political. There's a lot of you know, money to be made. There's a lot of politics. There's definitely a warming. I'm not going to deny that the Earth is warming, but it's warm. It's been warm before. It's been cold before. We saw that whole valley some of us were in yesterday was filled with glaciers, right? There's some other things driving that. CO2, yes, can control the climate to some regards, but so can the sun, volcanic activity. There's a lot of other external forces that can drive that. So that's my general opinion. And I think we have to be careful of linking a warmer climate to extremes, right? Because what is an extreme? An extreme is something that doesn't occur very often, so you need a longer period of time to observe that extreme, which we just don't have that data necessarily in a lot of realms. The warmer climate is going to probably produce more flooding type events with warmer air holding potentially more moisture, and some of the statistical data or some of the weather data is kind of showing that. But yeah, that's how I hope I answered that question okay. So, but yeah, so further studies needed. You know what? I am super excited to be around 30 years from now, and I hope Al Gore is too. And we'll see who's right or wrong, right? I mean, really, in fact, I took a picture of the sign on top of Glacier yesterday of, saying that the glaciers won't be there in 2020, which is 5 years from now. So we'll see what happens. Yes?
From a claims perspective, I know you guys are talking on hurricanes, but a lot of the money that insurance companies have to pay these days that you really don't owe coming out of these hail claims. Could you put a way to use this weather data to help us in that? And I'm finding that it's accurate to tell me if a hailstorm did occur there, but not so much to prove that one didn't. Can you speak to that?
Yeah, so, sorry, my mic went off, but I'll speak a little louder. So hail data, really the best data we have is from 1950, but really in the last 10 years, and particularly the last 5 years, we have radars now, and using radar data, so like at BMS, through various climate, we subscribe to radar data, that there's hail algorithms that can help us determine, with ground location, verification, and the radar data is going to cover a much bigger area and be more exact of where hail might have occurred. But that also is, now we're starting to build a better climatology of that, of where is hail occurring. So to answer your question, it's not necessarily hail size, it's duration, how long it hailed, and looking at even the probability of hail from the radar, of when it occurred. So you got to apply all those variables, duration, size, and probability, to really determine if hail's occurred at a particular location, along with verification. But now in social media too, it's super easy to integrate some of that into your claims process. If you're seeing tweets of pictures of hail, just hashtag hail, WX, which is weather, hashtag WX in your state, there'll be hundreds and maybe thousands of pictures of hail, people snapping hail. Oh, it hailed at this location, right? And you can just instantly verify, yeah, hail fell in that area. Yeah, I'm huge on social media and verifying claims data and where to send, telling clients where to send, resources and these sorts of things.
Well, that social media goes right to the same concept of it's much easier to confirm, look at, verify that it did occur there. I'm very interested in how to prove that it didn't occur there.
Yeah, I think looking at so we do that. Fraud's a big thing. So looking at the radar data with the reports, overlaying the swath, this doesn't necessarily need to be severe storm relativity. This could be like today's hail swath of where that is, where the policies are located, and integrating that in your daily claims. So, our company, every day we send out a product to our clients that wish to have it that says, here's the number of policies that were impacted by hail, then they can say, okay, was today a severe weather event, severe day? They can go into the system and see, where they should start to see claims, and then a month or a couple, as the claims roll in, they can start to verify that, right? You can type in the policy number. Is that in the hail swath? If it isn't, the radar data is pretty hard to lie against nowadays. There's pockets in the U.S. I'm not going to say there's not pockets in the U.S. that don't have bad radar coverage, like northern Minnesota and these sorts of things, but definitely in the heart of where hail happens, there's good coverage. So, yeah. Hopefully that answered your question.